Welcome to lecture number 35 of fuzzy sets, logic and systems and applications. In this lecture, we will discuss extension principle. So, the extension principle is very interesting, and with the help of the extension principle, we basically convert or transform a fuzzy set which is defined in one universe of discourse into another which is defined in the other universe of discourse. So, the extension principle is a basic concept in the fuzzy set theory that provides a general procedure for transforming fuzzy set from one universe of discourse to another universe of discourse, provided the mapping function, that means the f which connects one universe of discourse to another universe of discourse is known. And this procedure generalizes a common point to point mapping of a function, that is f, to a mapping between fuzzy sets. More specifically, f is a function from x universe of discourse, that means the universe of discourse capital X to universe of discourse capital Y. And if we take, let us say, to understand any fuzzy set which is defined in the universe of discourse capital X. So, if we take A x here, so normally we write a fuzzy set by simply either A, B or C like that, we never write normally A of x, but here since we are putting an emphasis on the generic variable with which it is defined, that means we are indicating here that A is defined in the universe of discourse capital X. So, A here is A of x, and this is defined by this equation here, means this fuzzy set here, where we have the membership value and then its corresponding generic variable value. So, mu A of x 1 by x 1 plus mu A x 2 by x 2 plus and so on plus mu A of x n by x n. So, here if we see A is defined in the universe of discourse capital X with the generic variable small x. So, if we are interested in transforming this fuzzy set into the universe of discourse capital Y, that means if we transform this fuzzy set A x into say B of y, where y is the generic variable in the universe of discourse capital Y. So, then how we can manage to do that is shown here. So, we see here that A x is transformed into B, where B is nothing but it is defined by the generic variable small y in the universe of discourse capital Y, and this is defined by this fuzzy set here mu A x 1 by y 1 plus mu A x 2 by y 2 and so on plus mu A x n by y n, and then these small y I means y 1, y 2, y 3 and so on till y n can be found by substituting x I values, that means x 1, x 2, x 3, x 4 and so on in f x I. That means, we use the mapping function to manage to get the conversion of the generic variable, let us say x into y. So, this can also be written like this. So, small xi is equal to f inverse of yi for every I is equal to 1, 2, 3, 4, 5 and so on up to small n. So, this way the extension principle helps us in transforming a fuzzy set which is in a particular universe of discourse into another fuzzy set which is in a different universe of discourse, say y. So, extension principle helps us in managing this conversion. So, let us now understand this further. In continuation to this, if this f x, if this mapping function is, which is here, is many to one mapping, then there exist x 1, x 2 that are belonging into capital X as the universe of discourse, where x 1 is not equal to x 2. So, in that case what will happen, f x 1 is equal to f x 2. So, this is a situation where let us say we have two values of generic variable x 1 and x 2, and then their corresponding f x 1 and f x 2 both are if equal. So, if both of these are equal, means if f x 1 is equal to f x 2, and also when we say f x 1 is equal to f x 2. So, it means it is having some value, let us say, that is y star, and this y star is belonging into capital Y universe of discourse. So, what does this mean? This means that if we have any two generic variables, if we have any two generic variable values x 1, x 2, and they are not equal to each other, but f x 1 is equal to f x 2, then in that case what we do is here. So, what we do here in this case is the membership value of fuzzy set B at y is equal to y star. Y star is the value which is f x 1 or f x 2. So, this y star will play an interesting role here. We see that how do we find corresponding to this y star mu b y star. You see here that mu b y star will be equal to the max of mu a x 1 and mu a x 2. So, this means that even when the f x 1 is equal to f x 2, but x 1 is not equal to x 2. So, in that case what happens, mu b y star is taken as max of mu a x 1 and mu a x 2. So, this can also be written as mu b y, which is here. So, the general formula can be like this. So, mu b of y is equal to max over x, which is again belonging into the f inverse of y, and mu a of x, which is written here. So, this is followed when we come across this situation. This situation means when, I am just repeating, the situation where x 1 is not equal to x 2. Please understand. Here x 1 is not equal to x 2, but f x 1 is equal to f x 2. So, we will take an example ahead to make it more clear. So, that is how we are able to convert or transform the membership functions from one domain to another, from one generic variable to another, from one universe of discourse to another. So, here very clearly we have transformed A into B A is defined in the universe of discourse capital X, where B here, which is transform fuzzy set, is defined in the universe of discourse capital Y. So, this is called the extension principle. So, let us take again here other examples. We are taking this example also to make you understand the extension principle better. So, we have taken an example here, and in this example we have taken a fuzzy set A fuzzy set, which is a discrete fuzzy set, of course you can see, and this discrete fuzzy set A is defined in the universe of discourse capital X. So, that is why small x is mentioned here. Small x is the generic variable, and which is nothing but belonging into the universe of discourse capital X. Now, this is very simple, this is very clear, very easy to understand that we have a simple discrete fuzzy set A, which has 5 elements. Now, our job is to convert or transform this fuzzy set into By, and here the new fuzzy set, the transformed fuzzy set, you see it is defined in the universe of discourse Y, and this is possible when the Y is equal to f x, that is the mapping function. When this is known, this is possible. So, let us do that. And here this problem will include the universe of discourse, which is mentioned here, that is from -10 to 10. So, let us now use the extension principle for mapping function, and let us move ahead. Mapping function is given in this problem. Mapping function is f x, and f x here is x square plus x minus 3, which is here. So, the transform fuzzy set, that is B of y will look like this, of course. Now, we have to find its membership values corresponding to its generic variable values small y's. So, let us now quickly move ahead and let us see what we do to get this. So, we simply write here the fuzzy set A, which is in the universe of discourse capital X, and then we write the mapping function. This is the mapping function. So, it is very easy to convert A x into B x, and we simply write B y in terms of mu B y over y's, and then we find the values of mu B y's and y's, means the membership values corresponding its generic variable values. So, the mapping function is here, this is given, and here we have the fuzzy set, this is also given. So, I am just writing that given fuzzy set in the universe of discourse capital X. So, since in this discrete fuzzy set we have these generic variable values -2, -1, 0, 1, 2. So, let us first compute the generic variable values, that means the y 1, y 2, y 3, y 4 and y 5 in the universe of discourse capital Y, and this is very easy to compute because we have the mapping function with us. So, what we need is here, let us say the mapped fuzzy set that we are interested in is B y, B of y, then what we need here is corresponding to A x, we need here is mu y 1 y 1, mu y 2 y 2, mu of y 3 y 3, mu y 4 of y 4, mu y 5 y 5. So, the unknowns are y 1, y 2, y 3, y 4, y 5. Mapping function is given. So, let us first compute y 1. So, our y 1 is here. So, since the mapping function is known, we just substitute the value of x, that means for x 1 is equal to minus 2, we are getting our y 1 minus 1. Similarly, for x 2 is equal to minus 1, we are getting y 2 minus 3. For x we are getting y, for x 3 we are getting y 3 as minus 3, x 3 is 0 here. So, for x 3 is equal to 0, we are getting y 3 is equal to minus 3, x 4 is equal to 4, we are getting y 4 as minus 1, x 5 is equal to 2, we are getting y 5 3. So, this means that the mapping function is helping us to compute y 1, y 2, y 3, y 4, y 5 corresponding to the generic variable values defined in the universe of discourse capital X. So, when this is known, then we directly substitute this in the equation B y here, this equation, this fuzzy set. So, all y 1, y 2, y 3, y 4, y 5 are basically substituted, and please understand that here this is mu x 1, mu x 2, mu x 3, mu x 4, mu x 5. So, that means when we substitute the values of mu x 1, mu x 2, mu x 3, mu x 4, mu x 5 and y 1, y 2, y 3, y 4, y 5, then we get this equation. So, this means we get a transform set like this. So, transform fuzzy set is a B y fuzzy set. So, I am again writing here how are we getting, just to make you understand better. So, this we have got by just substituting these values, mu x 2, mu x 3, y 3, mu x 4, y 4, then mu x 5, y 5. So, when we substitute these values mu x 1, so mu x 1, mu x 2, mu x 3, mu x 4 and mu x 5, these values we have already got with the equation A x. That means, in fuzzy set A x we already have these values. So, we do not have to compute this, we only have to compute y 1, y 2, y 3, y 4, y 5. That means, the generic variable values in the universe of discourse y, and this has to be computed by using the generic variable values in the universe of discourse given, that means, the capital X, and this is possible because we have the mapping function available, that means y is equal to f x is available. By using this here we get y 1, y 2, y 3, y 4 and y 5. And when we substitute, finally we get the transform fuzzy set B of y, and it is very clear that this B of y is defined in the universe of discourse capital Y. So, when we substitute mu x 1, mu x 2, mu x 3, mu x 4 and mu x 5 and also y 1, y 2, y 3, y 4, y 5, then we get here this fuzzy set. But when we rearrange this, what we see is this situation. So, this situation is a situation of conflict. That means that for the generic variable here, for the same generic variable value, that means y is equal to minus 1, we have two membership values. So, y 1 is equal to minus 1, we have 0.1 as the membership value, and again here also y, this is y 4. So, y 4 is equal to minus 1, we have 0.9. So, this means for the same value of the generic variable we are getting two membership values, and this is the conflicting situation. So, which one to keep, because we can only have one membership value. So, we take the max of 0.1 and 0.9. So, max of 0.1 and 0.9 is 0.9. So, that is how we avoid this conflicting situation by keeping 0.9 for the generic variable value minus 1. And then finally, we have our B y, the transformed fuzzy set in the universe of discourse, that is B of y 0.9 over minus 1, 0.8 over minus 3 plus 0.3 over 3. So, here we have two conflicting situations. One was for minus 1 as the generic variable value, another one for y is equal to minus 3. So, these two have been avoided, and then finally, we have the transform fuzzy set which is B y, and this is very clear that we have got it from A x which was given, and this A x was defined in the universe of discourse capital X, and this was possible, or this is possible with the help of extension principle. Now, let us take another example here. We are taking another fuzzy set which is again defined in the universe of discourse capital X, and this capital X range here is given, that is minus 50 to 50. So, all the generic variable values will be within the limit that is given, that is minus 50 to 50. So, we have the fuzzy set A, and let us now use the mapping function which is also given, that is y is equal to minus 3 x square plus x. So, this is a mapping function. If the mapping function is not given, then the conversion is not possible. So, let us use this mapping function y is equal to f x, that is minus 3 x square plus x, to compute y 1, y 2, y 3, y 4 and y 5 in this case. So, let us now quickly compute these values. So, for x 1 is equal to 0, we have y 1 is equal to 0, x 2 is equal to 1, we have y 2 minus 2, x 3 is equal to 2, we have y 3 minus 10. x 4 is equal to 3, we have y 4, x 5 is equal to 4, we have y 5 is equal to minus 44. So, what we have here is y 1 is equal to 0, y 2 is equal to minus 2, y 3 is equal to minus 10, y 4 is equal to minus 24, y 5 is equal to minus 44. What else do you need to write the transform fuzzy set, that is capital B of small y? So, we already have y 1, y 2, y 3, y 4 and y 5 computed by using the mapping function. So, yes, so we have to now find mu b x 1, mu b x 2, mu b x 3, mu b x 4 and mu b x 5. So, let me tell you that we do not have to do anything, we do not have to do any calculation, we simply write here the mu b x 1 is equal to mu a of x 1. And as I said that this mu of y 1 is going to be equal to this. This means that we do not have to compute this, we have to just keep these values, just take these values and this gets automatically transferred into the other universe of discourse, means mu of y I is equal to mu of x I. So, when we apply this, we see that mu b of 0 is 0.2 and then mu b of minus 2 is 0.7 and mu b of minus 10 is 0.5, mu b of minus 24 is 0.6, mu b of minus 44 is 0.1. So, I can write here one more equation and this is mu x 1 over y 1, then mu x 2 over y 2, then mu x 3 over y 3, then mu x 4 over y 4, then mu x 5 over y 5. So, this way we are able to get the transformed fuzzy set B y in the other universe of discourse, that is capital Y. But here we have seen that for this transformation we should have the mapping function which is connecting the universe of discourse x and y is known. Now, let us take another example here, which is the case of a continuous fuzzy set. So, here we are taking a continuous fuzzy set instead of a discrete fuzzy set as we have seen in the previous example. So, here we are taking a fuzzy set mu fuzzy set A, where mu A of x is Gaussian like this. So, we can write it like this, and let me tell you that this fuzzy set is defined in the universe of discourse capital X. So, we can write it like this. Now, the mapping function is also available. So, mapping function is this is our mapping function, and this mapping function says y is equal to f x, and this is equal to x square minus 3 when the generic variable values x is more than 0, and it is the f x is x when generic variable values are either less than or equal to 0. So, when we use this mapping function and the fuzzy set that is given, which is defined in the universe of discourse X. So, let us see how we write or how we find the fuzzy set B, which is defined in the universe of discourse capital Y. So, here you see figure A is the plot of given fuzzy set A. You see here, this is given, that is the Gaussian fuzzy set. So, we can write here the fuzzy set A, and figure B is the plot of given mapping function. So, here is the mapping function which is given to us, see here. So, we see that we have the f x, here we have the f x. So, we see x axis and y axis, and then we have the mapping function defined here for all values of x when it is greater than 0, the f x is x square minus 3, that means this part, or I can say that when the x values are more than 0, the f x becomes x square minus 3, and when the x is either less than or equal to 0, the f x becomes only x, means this part. So, f x is known to me here. Now, let us find B. So, we clearly see that let me first tell you what is figure C here. So, figure C is the fuzzy set which we have obtained after employing the extension principle. So, I am going to explain you as to how we are going to get this fuzzy set B, and this B fuzzy set is in the universe of discourse Y. So, we see that if we take up f x, we take up the mapping function here. So, for some value of x here, let us say we have x 1, and then let us say we have x 2, let us say this is my x 2. So, this means that when x 1 and x 2, these two are the different values, for these two values x 1 and x 2, we see that we have here the same membership value. So, when we apply the extension principle here, so this says that if we have, we can clearly see here, if we have x 1 and x 2 like this, which is belonging into the universe of discourse capital X, and if they are not equal as we have seen here, in this case I am making this again, let us say this is my x 1 and let us say this is my x 2, and we see that we are for these two different values of x, that means x 1 and x 2, we are getting same y, and we can call this as y star like this. We have our x 1 and x 2 which are not equal, but we are getting f x 1 is equal to f x 2, and here y remains the same for these x 1 and x 2. So, we call this as the y star, and of course, this y star should also belong into the universe of discourse Y. So, in this case what happens? In this case what we do here is that we take the max of the mu a x 1 and mu a x 2. That means, we see here if we take the mu x, what is the mu x? This is x axis. So, generic variable mu here, and then my mu of x 1 will be this, and my here this is mu of x 2. So, what we are doing here is we are getting two mu values, two membership values corresponding to two generic variable values, that means x 1 and x 2. We are getting mu x 1, mu x 2, and mu x 1, mu x 2 are different, they are not the same. So, what we do here is we take max of these two. So, when we take max of these two, it is very clear that mu x 1 is the winner. So, we retain mu x 1 because mu x 1 here in this case, I am talking about this case only. So, in this case mu x 1 is greater than here mu x 1 is greater than mu x 2. So, mu b y star. So, what will be the membership value corresponding to this generic variable value in the universe of discourse y, that means the star y star. So, mu b of y star is nothing but it is going to be the max of mu a x 1 and mu a x 2. And by using this, what we get is here. So, we see that the corresponding y is here, corresponding y is y star. So, y star is here, and corresponding to this y star, the mu is here, this is mu b y, this is mu b y star, and this is nothing but max of mu x 1 and mu x 2. So, that is how we keep getting the corresponding mu b values, means the membership values. So, here in this problem or in this example, what is happening is that for the range here, which is shown by this dotted line, this and this, we see that here we see that in between this we have x values, where we are getting same y values for two x values. Means, in other words, I can say that for multiple values of x we are getting the same y. I should not say multiple, but I will say the pair of x. So, this is the range in which more than one value of x we are getting the same y. So, that is why here this range, in this range we apply the max condition, and then after this range we do not have to worry, because we are going to get the only 1 to 1 mapping. So, that is how when we apply this we are going to get this shape. So, this is what is our mu b y, which is nothing but the membership function in the universe of discourse capital Y, and this is for the fuzzy set B. So, I can write here that the resulting function B is like this. So, this way we apply extension principle in order to map from one universe of discourse to another for the fuzzy set A transforming into B. So, now if we have, let us say, the mapping function in n dimension, means if we have a mapping function like f of x 1, x 2, x 3 and so on x n. So, then how can we map this to y? So, suppose a mapping function f is in the n dimensional universe of discourse, that means capital X 1, capital X 2, capital X 3 and so on, capital X n, and we are mapping this to the universe of discourse y. So, this means that we have y is equal to f of x 1, x 2, x 3 and so on x n. And here let us say we have the fuzzy set which is defined in the universe of discourse x 1, x 2, x 3 and so on till x n. So, how can we transform the fuzzy set B which is in the universe of discourse capital Y, and this is what is the mapping function that is given to us. This is mapping function. So, in this case the extension principle helps us in finding the membership values, that means the mu b of y, where this mu b of y will be equal to the max over x I 1, x I 2 and so on x I n is equal to f inverse y of min I mu a I of x I, and this is when we have f inverse y is not a null set, and mu b of y will be 0 if f inverse y is a null set. So, this is how we can manage to map the n dimensional space into the single dimensional space, that means x 1, x 2, x 3 and so on to x n into y. And with this I would like to stop here, and in the next lecture we will discuss the composition of fuzzy relations. Thank you.